आज दोबारा आप एक सेकंड सेशन ऑफ कॉम्प्लेक्स नंबर के सेकंड सेशन में आपसे मैं आपका स्वागत है। मैं आपको कॉम्प्लेक्स नंबर को आगे बढ़ाता हुआ आगे सवाल करूंगा जो कि हमारे एनडीए में पूछे गए हैं। और देखिए कितने आसान से सवाल हैं, कितने ट्रिक से आप करेंगे। इट्स अमेजिंग टू गो, वेरी अमेजिंग। सो हम बता दें, हमने आपको बताया था कि जेड जो है एक कॉम्प्लेक्स नंबर है, उसको ए प्लस आयोटा बी में लिखेंगे। तो मैंने बताया था कि इसको हम आर इंटू में कॉस थीटा प्लस आयोटा इंटू साइन थीटा लगाएंगे। जो आर जो है वो मैग्नीट्यूड ऑफ इसका आर है और ए स्क्वायर प्लस बी स्क्वायर का अंडर रूट है। और आर्गुमेंट ऑफ जेड इज इक्वल टू थीटा, जिसका नाम हमने टेंजेंट इनवर्स वाई ओवर एक्स कहा था। हमने कहा था कि प्रिंसिपल वैल्यू निकालनी हो ऑफ आर्गुमेंट की प्रिंसिपल वैल्यू निकालनी हो तो थीटा की वैल्यू पाई और माइनस पाई के बीच में होगी। हमसे सवाल कई बार पूछा गया है कॉम्प्लेक्स नंबर का आप मैग्नीट्यूड बताओ और एम्पलीट्यूड बताओ, ये हमसे पूछा गया, बहुत बार पूछा गया कि व्हाट इज द एम्पलीट्यूड एंड व्हाट इज दिस। मेरा पहला सवाल मैं पूछ रहा हूँ कि व्हाट इज द एम्पलीट्यूड ऑफ, व्हाट इज द मैग्नीट्यूड ऑफ अंडर रूट 2 प्लस आयोटा डिवाइड बाय अंडर रूट 2 माइनस आयोटा का मैग्नीट्यूड क्या होगा। व्हाट इज द क्वेश्चन आस्क्ड इन एनडीए क्वेश्चन। Don't start here by doing rationalization. Please don't find out in this way. No, we do the argument of this argument of this. Use the formula Z1 upon Z2 is equal to, I told in my first lecture, go to my first lecture in that case, just ये आ जाएगा अलग, और this is equal to what, the under root of this minus iota. Well friend, this is equal to this square plus 1, this one under root this square and plus 1, okay, is always equal to 1. This is 1. Simple question. The trick is simple to go, not to rationalize. Don't do rationalization there in the examination. Apply this result. Don't go the rationalization. Warning to you friend, don't go to the rationalization and simplify. Look at this, 1 plus 2. This question was asked in NDA. Find the magnitude of, find the modulus of this, find the modulus of, okay, let's simplify. 1 plus 2 iota, simplify, 1 plus iota square minus 2 iota square minus 2 iota. Well, this is required, iota square minus 1. 1 plus 2 iota divided by 1 plus 2 iota, okay, they are equal, therefore it is equal to 1. That's nothing is there. That's here, that's simple question, and that cancel and answer is equal to 1. Some questions are asked based on the magnitude. I told you this is the one to go. Well, I did in my first video to find the equation. Like this question was asked in NDA, 1000 iota raised to 1001, iota raised to 1002, and iota raised to power 1003. This is equal to what? This is equal to this divisible by 4, 1 divisible by 1 iota की power 1. Iota square and iota cube. This is equal to minus 1 and this is equal to minus iota cut. I said iota raised to the power 4n is equal to 1. Iota 4n plus 1 is equal to iota, and iota raised to 4n plus 2 is equal to iota square is equal to minus 1, and iota 4n plus 3. If you divide by this 4, remainder 3 to iota cube, and this is equal to minus iota. Remember this property and you get it. That's here to go. This is the simple question was asked and that we have done. Now next one is another question was asked in the was 1 plus iota square plus iota raised to power 4 plus iota raised to power 6 and up to iota raised to power 100. Okay, let's get the answer. Let's get this answer. What is the answer of this? What is the answer for this one is? Tell me, what is the answer for this? Well, I just give time to you. Let's hear. Iota, this one, this. How many they are? 2, 4, 6, 8, 1, 2, 3, count 50. These are 50 and this is 150. 1 plus iota square plus iota raised to power 4, iota raised to power 6. And iota raised to power 100. दोस्तों, there are 51 terms in this. There are 51 terms. Remember 51. Iota square is equal to minus 1, cut. This is equal to 1 and this is equal to minus 1, cut. They are cut. Left is iota raised to power 100 and this is divisible by 4. Therefore, his answer is equal to 1. So quick, so quick. This is the technique to do. Find out what is number of terms and then decide what iota square is equal to minus 1, iota raised to power 4. When you divide this one, you get the answer. That is the one. This is the basic thing to do. Well, this was my one type. I just in first video explained to you how to find the argument and how to find the magnitude of these one. So this is the one. I'll be doing some question. What is the magnitude? What is the question? What is the argument or amplitude of this their one? 1 plus under root 3 iota divided by under this one. This was the question asked in the examination. Friend, I find some student doing the rationalization here. I have seen the student doing this. Okay, this is nothing. This is 1 over under root 3 plus 1. It makes only the magnitude. Does not make anything. This is the magnitude. They were going to do as the magnitude. I'm interested to know about this. What is the argument? Is it tangent inverse under root 3? This is under root 3. This is divided by this. Answer upon 1 is equal to pi by 3. That is the answer. You just find tangent inverse. No need to rationalize here. Don't do the rationalization. Don't fall in the trap that what our examiner want to test you. This is the one. So whenever they ask you find the argument, so you just do the question that has been asked and look at this. Let's look at 1 minus under root 3 iota divided by 1 plus under root 3 iota. Find the argument. What is the argument of this? What is the amplitude of this complex number? What is the amplitude? I just had in the morning in a video the argument of Z1 and Z2 is equal to argument of Z1 plus argument of Z2. Let me just remind you. Argument of Z1 upon Z2 is equal to argument of Z1 minus argument of Z2. This is it. I'll be using this concept here. I'll be using this concept. This is I'm going to use I am not going to rationalize, friend. I am not going to rationalize this. I don't want to rationalize and find the question. Let me do the question by using the polar form of it, and then do it. Let me do the polar form. First of all, I want to write down in the polar form of this. I want to write this. 1 plus under root 3 iota. If I find I told in the morning in my first video how to find. This is the first quadrant. This is the tangent inverse under root 3 divided by 1. No problem. It is equal to what? Pi by 3. Okay, done. This is pi by 3. Alright. If I look at this argument of this is 1 minus under root 3 iota. This is tangent inverse. I put the modulus here. I don't take the negative sign. It is equal to pi by 3. But it lies in which quadrant? X positive and Y negative. X positive and Y negative. That means it lies in fourth quadrant. And it is theta here. I said yes. In my first video, it is pi minus theta. And it is the second quadrant. Let me remind this. This is here. So what is the argument of this one is equal to minus pi by 3. So what is the formula for what is the argument of this total is equal to? This is equal to minus pi by 3 and this is pi by 3. So go on the top minus pi by 3. Z1 argument of this one minus argument of this is equal to minus 2 pi by 3. Okay. This is minus 2 pi by 3. So I go to that part. This is we go with this concept. This is minus 2 pi by 3. It means I make 2 pi by 2 pi minus 2 pi by 3. So my answer is equal to 4 pi by 3. This is the amplitude of this. So we can find the amplitude of this Z1 upon Z2. We can get into it. This is here it is. So whenever you find the magnitude of Z1 upon Z2, you can go into this detail. So when I get into these questions, I have the I come across the many questions like this. So let me do one more question based on it, and let's say argument of this 1 plus iota into under root 3 plus iota raised to the power 6 divided by 4 into 1 minus under root 3 iota raised to the power 2. I want to find the argument or amplitude of this one. Well, what is the argument of iota is equal to? What is the argument of this is equal to? What is the argument of this? So, to find the argument of this, and raised to the power 6, I have to multiply. So, I have to do a shortcut here, and I want to tell you the one important point, how to get into this raised to the power 6, how you do raised to the power 6, and how can be done. Let me explain to you. Friend, here this raised to the power 6 question comes, I reminded of, I just write down, iota is equal to, I write iota is equal to 0 plus 1 into iota, 1 into iota. I write here, this is cos 90 is equal to 0 and sin 90 is equal to 1, sin 90 and into iota. So here we have got argument of iota is equal to pi by 2. Remember, if you got a purely imaginary number, I told in my first video, when you got purely imaginary number, complex number, the answer will be 19. And if you got a real number, the argument is equal to 0. That is a real number on real axis, and this is on the imaginary axis. I come down here, under root 3 plus iota raised to the power 2. Before I start this, let me explain to you. E iota theta is equal to cos theta plus iota into sin theta. Okay, this we have taken. Well, I want to find cos theta plus iota sin theta if you got, and raised to the power suppose n. So what happened is equal to E iota theta raised to the power n. This is equal to E iota n theta, and this is equal to cos n theta plus iota into n sin theta. Friends, here we go a 1. If you got this equation like this happens like this. Can you find in this form, then raise to the power anything, you multiply, get into it. This is called Demar's theorem. This is theorem is cos theta plus iota sin theta raised to the power n is equal to cos n theta. They must be in form cos and sin iota into sin n theta. Not otherwise, not sin and cos here. It should be in this form. That is the one. So this is the Demar's theorem. You can multiply this and cos theta plus iota sin theta. Let me come to this point now. Now here, if I come across this point, I just go this question now. This is, I found the argument of the iota is equal to pi by 2. I want to find the argument of this. Let me ask this question first. What is the argument of this? Argument of this point. Okay, I just write down this is equal to r cos theta, this is r sin theta. So let me have under root 3 by 2 plus 1 by 2 iota, and 2 से multiply 2 raised to power 6 here. I just had 2 here, 2 raised to power 6 outside. This way I got 2 raised to power 6. This is equal to, this is cos pi by 3 plus iota into a sin pi by 3. This is here. Cos pi by 3 and this is 2 pi by 3. This is the answer here. And then friend, here 2 raised to cos 30, cos 60, cos pi by 6 here, sorry, cos pi by 6, cos by 6. Now here, and I multiply this Demar's theorem, it is 2 raised to power 6, it is cos pi plus iota into sin pi. दोस्तों ये मेरा रहा इसका इस वाले का आर्गुमेंट क्या होगा, इसका आर्गुमेंट पाई, इसका आर्गुमेंट क्या था पाई/2, ये दोनों मल्टीप्लाइड थे प्लस में पाई, ऊपर वाले का आर्गुमेंट ये आ गया। नीचे की बात करूंगा, छोड़ो यहाँ की बात, नीचे की बात करूंगा कि निचले वाले का आर्गुमेंट क्या है। मैं आपको बता दूं इसका आर्गुमेंट क्या, 1 माइनस में √3 आएगा। आई विल नॉट ओपन द स्क्वायर, मैं स्क्वायर नहीं खोलूंगा, मैं यहाँ 2 से मल्टीप्लाई करूंगा, यहाँ पर 2 की पावर 2 यहाँ आई, 4 गुना में ये कॉस यहाँ पर 30 और माइनस में साइन 30 ये वाला इंटू आयोटा रेज़ टू पावर 2। क्योंकि यहाँ पर कॉस पॉजिटिव है और साइन नेगेटिव है, तो यहाँ पर आप देखेंगे कि यहाँ पर कॉस पॉजिटिव, यहाँ पर कॉस पॉजिटिव है और साइन नेगेटिव है, तो कौन सा क्वाड्रेंट होगा, ये माइनस लगा दूं, ये फोर्थ क्वाड्रेंट में लगा दूं, यहाँ पर इनकी माइनस लगा दूं, यहाँ आया और इसको 2 से यहाँ पर मल्टीप्लाई करूंगा तो 4 इंटू में कॉस -2 पाई/3 और प्लस में आयोटा इंटू में साइन -2 पाई। दोस्तों इसका क्या आया, व्हाट इज आर्गुमेंट ऑफ दिस इज इक्वल टू -2 पाई/3 आर्गुमेंट डाउन, और नीचे होता तो ऊपर जाके प्लस हो जाएगा 2 पाई/3। तो मेरा यहाँ पर मेरा जो आंसर आया वो क्या आया, यहाँ पर 2 पाई/3 90, 3 पाई/2 प्लस 2 पाई/3 इज इक्वल टू 6, it is 9, 14, 13 pi/3. 13 pi/3 means 2 pi here and pi/6. So argument of this is equal to pi/6. The argument of this total question was equal to pi/6. I hope you have understood or not, I don't know. Let me do again. Let me tell again how to find the argument without opening, without doing anything. You have to find out the question, how to find the argument of a question. This is, well, I do another question to go to find the argument of this type of question. So here let me talk. What is the argument of √3 plus iota raised to power 17? What is it? And I will do this 1 minus iota raised to power 50. I am interested to know what is their magnitude and what is its modulus. My question to you: how to calculate the modulus and how to find the amplitude of this. This is a question I am doing. Well, friend, I just do here 1/2 and 1/2 here and 2 raised to power 17 this side, 2 raised to power 17. This is equal to cos pi by this is cos by 6 plus sin pi by 6 into iota raised to power 17. This is here. Now I multiply this 17. 17 pi by x, 17 pi by 6 is the argument. What is the modulus? 2 raised to power 17. This is the modulus, and this is equal to 5 pi by 2. Divide करेंगे 2 pi plus 5 pi by 6. So what is the amplitude of this complex number is equal to 5 pi by 6. That is here. I hope you understood. If you not understood, come here downwards. This is here. I do under root 5 raised to power 50 here. 1 over under root 2 minus 1 over under root 2 into iota raised to power 50 here. This is the magnitude. 2 raised to power 25 is the magnitude of this complex number. Modulus of z is equal to this. This is equal to sin 45. This is equal to cos 45. And this is sin 45. But since it is minus here, so minus and minus here. When I multiply by 50, the amplitude is equal to what? Is equal to minus pi by 4 into 50. It's equal to 2 and 25. Minus 25 pi divided by 2. It's equal to minus 2 pi 24. 12 minus pi by 2. Go on here. And this is equal to, answer is minus pi by 2. We can have. The amplitude is minus pi by 2. This is how you find the question to find the modulus or amplitude of a complex number. That is what we do, find the complex number. Before I just go, I just want to introduce you the complex number, conjugate complex number. My topic will be conjugate complex number. conjugate. I want to do this complex number, conjugate complex number. This is my next topic is to conjugate complex. Well, if I want here z is any complex number a plus iota b, then z bar is equal to a. This is the conjugate. Z bar is equal to minus changes in there. If this complex number is here, a and b, then it's a reflection here. Z bar will be here. It's a and b minus. This is the complex. This is z. This is z bar. Here, if this argument, the modulus of z and modulus of z bar is same, and if you say z into z bar is equal to z into z bar is equal to a plus iota b into a minus iota b. Okay, this is equal to a square minus iota square b square is equal to a square plus b square. Friend, this is equal to modulus of z square. Very important property of the complex number is conjugate is modulus of z square. This is there. This is one of the important property. I am using it. This is modulus of this part. Well, my next part is to go with the complex conjugate numbers. Conjugate means what conjugate here is, if I have the complex number z1 plus z2, conjugate is equal to z1 plus z2 here. If I got z1 into z2 conjugate, this is z1, z2 separately, z1 upon z2, x here, it's equal to separately. The conjugate has such properties. This is what we conjugate more than ये वाली हमारी बात. दोस्तों हमारा conjugate का सवाल conjugate what will be conjugate of this? The question asked to you, what is the conjugate? What is the conjugate? The conjugate of 1 plus 3 iota square. So you have to write in the form of a plus b. So I write 9 iota square plus 6 iota is the minus 1 minus iota plus 6 iota. This is it. So what is conjugate of this is equal to answer minus 8 minus 6 iota. You have to write in the form of a plus b iota. Don't write this only 1 minus. This will not be the option you have to answer in this case. So the conjugate question asked that part. Well, conjugate, when I talk about the conjugate, what is the difference between the z is equal to a plus iota b, this is equal to r cos theta plus iota into sin theta, okay, r into iota theta. This z bar is equal to a minus iota b is equal to r into cos theta minus iota into sin theta. Well, I change here, this is cos minus theta plus iota into sin minus theta. So simple, the argument of z bar is equal to minus theta. I just said argument of z is equal to theta. So the conjugate has the argument is negative of z. That is it. We have done is this into this is equal to modulus of square, which is real. Argument of z plus argument of z bar is equal. Real argument is equal to 0. Therefore, argument of z is nothing minus argument of z bar. We can see from here also, from this property we can see. So, argument of z and z bar is always equal to 0. That part, argument of z and z bar has to be 0. So, when z is equal to r into e iota theta, then z bar is equal to r into minus iota theta. That is here to z bar. The conjugate has the argument of, suppose you ask the argument of, what is the argument of a plus iota b or divided by a minus iota b? Well, friend, the argument of this means argument of a plus iota b, and minus argument is conjugate. This is equal to theta. This is equal to minus of minus theta. It is equal to t theta. This is minus theta. So argument of a complex number divided by its twice of this numerator or denominator. What we have got the numerator here. So this is a question to go. Before I just finish my today's talk, I'll go back to a one question if alpha, beta are two. This has been asked in the ND examination. Two different complex numbers such that modulus of 1 is equal to b. This is given. Then alpha minus beta divided by alpha, no alpha, 1 minus alpha bar, beta bar, no. This is equal to what? This is equal to what? This is equal to what? Okay, well, I go with this. When alpha bar is equal to 1, so alpha square is equal to 1. It means alpha into alpha bar is equal to 1. I place this here. Okay, I don't want to tell the answer. Answer I have to tell you. Alpha minus beta. This place I put alpha and alpha bar, beta. Alpha bar common here. 1 over alpha bar modulus is equal to alpha minus beta and alpha minus beta. This cancels 1, and modulus of when this is equal to 1, then conjugate modulus is also equal to 1, and therefore answer is 1. This has been asked. The question has been asked in NDA, and if I write in another way, another form of this question, let me write down another form. If alpha beta are the two different complex numbers, if alpha beta are, I just finished this today's talk with the note of this question, which has been very simple, but has a trick. Modulus of 1 is equal to. There are two complex numbers such that this. Then you find beta minus alpha divided by 1 minus alpha by beta is equal to what? Choices are 0 is a 1 by 2, and C is equal to 1 and D is equal to 2. This has been asked in one of the questions. That is, well, here we go. This is the same question. In place of beta, this one bar, I can say this is equal to beta square is equal to 1. That means beta and beta bar is equal to 1. In place of 1, put it here. Beta minus alpha. In place of 1, इसकी जगह पर बीटा बार लिखो और माइनस अल्फा बार और बीटा। अब की बार में बीटा कॉमन लूंगा, बीटा माइनस अल्फा, बीटा बार माइनस अल्फा बार, और बीटा बार बाहर आया तो 1 आ गया। और ये आपस में कंजुगेट हैं। कंजुगेट का मॉडुलस हमेशा ही 1 होता है। आपको बता दें a प्लस आयोटा b और a माइनस आयोटा b का मॉडुलस लूंगा तो दोनों का अलग अलग करूंगा तो दोनों आपस में बराबर होंगे और दोस्तों ये इक्वल टू 1 होगा। ये इसका कंजुगेट है तो आंसर इज 1। सो आंसर सिंपल क्वेश्चन बट हैज बीन आस्क्ड इन इंडिया एंड नीड्स केयर, इट नीड्स स्लाइटली आपको इसके बारे में थोड़ा सा नोट करना होगा, ट्रिक है। और आप ये मेरा सवाल मैंने इस वीडियो में वो करे हैं जो कि जो एनडीए आए हुए हैं जो आप कर सकते हैं। मेरा अगला टॉपिक और फाइनल टॉपिक जो होगा वो हमारा क्यूब रूट ऑफ यूनिटी होगा। ओमेगा की बात करेंगे कॉम्प्लेक्स नंबर की, वो मेरा कल एक लास्ट टॉपिक होगा कॉम्प्लेक्स नंबर। आपको उम्मीद है आपको 2 सवाल या 3 सवाल कॉम्प्लेक्स नंबर के आसान से आते हैं। You can meet them and I will tell if they are difficult one. I just discussed 2-3 more difficult, that is of can I do furthermore which are asked in more competitive examination like engineering colleges. I'll discuss it. But these are the questions that is limited to the NDA. Hope you revise, you will get into it and do it. Thank you.